Hey everybody, I wanted to do a follow-up video to the motions of the sun activity that you did on Tuesday. And here we're using this motions of the sun simulator again. And we can use this to model what's happening in the sky at different times of the year, different locations, different days and times. And it allows us to see the path of the sun and how it changes. Now, just like the other video, what I'm going to do is uncheck some of these things. By default, it just opens up with the bottom of the celestial sphere. It's not a problem, but I think it's a little harder to look at that way. And I'm going to take off some of these other things, like the ecliptic here, which represents the plane of the solar system, but we don't really need that. So here's this yellow line represents the path of the sun. Of course, the yellow circle represents the sun itself. And here we have the little stick figure, which represents a person. And remember, the celestial sphere is basically just a theoretical concept. It's a model that represents what you can see. So your celestial sphere is wherever you are, and it's what you see when you look up. Directly over your head is what's called the zenith point. And then what you see along the horizon, and we have these compass directions here, north, south, east, and west. So today what I wanted to do is walk you through the second half of this activity, Path of the Sun, part 2. And we can see that here. So we have to, and this document will be in Google Classroom for you, but we have to get it to the proper settings. So latitude 41 degrees, day of the year, December 21st. We're at 40.8, that's close enough. But we need to change the date to December 21st, which is winter solstice, the first official day of winter. This represents the shortest day of the year, when Earth's axis for the northern hemisphere is tilted away from the sun. The North Pole would be in complete shadow and in complete darkness for roughly 6 months. Here in Goshen, in this area, we have some sun, of course, but not much. And we can see the sun is very low in the sky. We can see this yellow line representing the path of the sun is relatively short. And the sun is at its solar noon point, the highest point that it will reach in the course of this day. And we can see that the sun is in the southern half of the sky. I'm going to try to grab the whole thing here. When we look at it in this direction or in this direction, we can see the sun at this time of year is always in the southern half of the sky, and it's relatively low. It is never in the northern half of the sky. So let's go back to the settings here. We've got December 21st, 12 p.m. I think we're there, but let's just make sure. 12 o'clock p.m., yep. And let's see, you should be viewing the celestial sphere from the west. So we're looking to the west, so that makes sense. And let's see, click, we need to do the animation mode to step by day, 15 days per second. So we're going to do step by day, 15 days per second. Click start animation. And what we're doing now is, instead of time changing, the days are changing. So we're not changing the time, we're changing the day of the calendar, as opposed to what you did in the other activity where you were changing time. Now we're seeing what happens day to day to day, but we're leaving the time constant. So we're leaving time at noon, but we're changing days. So as we start the animation, we're going, December 21st, December 22nd, December 23rd. And each day we're looking at the sky at 12 o'clock noon. So let's check it out. We're looking to the west. And there we go. And now we can see as we go past December 21st, the sun is getting higher in the sky. I'm going to stop here for a second. The sun is getting higher in the sky. And as the sun gets higher in the sky, the length of this yellow line increases. The path of the sun is becoming greater, which means the amount of insolation, incoming solar radiation, is increasing. The duration of insolation, the length of a day, is getting longer, right? December 21st is our shortest day of the calendar year. And as we continue with the animation, we can see the length of the day is increasing and increasing. And now we get to March 21st. or there's March 22nd. Let's go back a day. March 21st, spring or vernal equinox. Vernal in Latin means spring. So now we're on spring equinox, and we see some interesting things. So we have a pretty long duration of insolation here. The equinox means equal. This is one of 2 days, fall and spring equinox, where the entire planet gets an equal amount of night and day. No matter where you live in the world, on an equinox, you're going to experience a 12-hour day and a 12-hour night. Now, if we keep going and we approach June 21st, summer solstice, which we're rapidly approaching, it's only a few weeks away, we can see the days getting longer. We get into May, and we're approaching June 21st. There it is. June 21st, longest day of the year. Now, there's a couple of interesting things to observe here. We have a very long duration of insolation. We can see the sun is very high in the sky. A common misunderstanding with this is, well, for one thing, this is the highest the sun is ever going to be for an observer in this region, which means that you will never see the sun directly over your head. The sun is always going to be in the southern half of the sky where we live. It might be very low in the sky if we're looking at winter. It might be very high in the sky in June. But it will never be directly overhead, which means we're always going to have a shadow. The only way we would never have a shadow is if the sun was directly over our heads. And we'll never experience that here in New York. The only way to experience that is if you get closer to the equator on the right day of the year. And that's a whole other lesson in itself. If we have a little bit of time, maybe at the end we can change to a place closer to the equator and see that. But where we live, we're always going to have a shadow. The length of the shadow depends on a couple of things. It depends on what season we're in. It depends on what time of day it is. And we can see that in June, we have a relatively short shadow because the sun is so high in the sky. Well, I'm going to start the animation again. Here's June 21st, first official day of summer. This is when the sun is highest in the sky, which means that as we continue with the animation and we go into July and August, we'll start to see the sun reverse direction and get lower in the sky. And remember that as the animation progresses, we're looking at a day at a time, and the time on the clock is being kept fixed. Well, it shifted to 1. Let's go back to 12. Anyway, here we go. So we'll continue with the animation, and we're going to see now the sun is moving back down. June 21st was its maximum, and now we're headed back down. And you've probably noticed this in August, end of August. Well, it starts getting dark earlier. And by the time September rolls around and it's time to start thinking about going back to school again, the days start getting noticeably shorter. And then we get into the fall and days start getting quite short. Here's September. And once we get into, let me go back a minute. Let's go back to September 21st. Here's first official day of fall, or autumnal equinox. And the sun is lower in the sky than it was before. Days are getting cooler and shorter. Duration of insolation is getting shorter. And if I continue with the animation, and we continue back down to December 21st, we can see the sun much lower in the sky. December 21st, shortest day of the year. Missed it by 2 days there. Let's change that to 21. Okay, shortest day of the year. And we can see it's very low in the sky, short duration. The time is no longer at noon. Let's change that. I'm going the wrong direction. What am I doing here? There we go. Anyway, sorry about that. Anyway, we can see that the sun is very low in the sky, short path to the sun. And as we continue with this animation, maybe we'll go through it one more time a little bit faster. We can see that throughout the course of a year, for our location, the sun is always going to be somewhere between roughly this point and this point up here. And the reason why is tilt of the Earth's axis. And we can see we get to June 21st, right about here. And once we pass June 21st, the sun's going to reverse direction, come back down, and we reach fall equinox right there, winter solstice right about there, short path to the sky, short path for a sun, and it keeps going back and forth and back and forth. So the sun is again never overhead where we live. We will always cast a shadow here in New York. And additionally, we'll never see the sun in the northern half of the sky. Something that I think is kind of interesting are solar panels. If you want to put a solar panel up to collect, and you can see, by the way, the length of your shadow increasing as the sun is getting lower. We see long shadows when the sun is low in the sky. I'll get back to the solar panel thing in a minute. So in the winter, we tend to have long shadows because the sun is lower in the sky. And we tend to have shorter shadows in the summer months, in the warmer months. And I'll get back to that solar panel thought in a moment. But we can see the shadow is getting shorter. And we're going to have pretty short shadows June 21st, followed by longer shadows at other times of the year. Now, we also have long shadows in the morning and at sunset when the sun is low in the sky. Now, as far as solar panels go, sometimes a question that you might see is what would be the best direction to aim a solar panel to get the most amount of sunlight? Most people say east because the sun rises in the east. Well, that's not a bad option, but you're only going to get half the sunlight that you could, because once you pass noon, well, now the sun is in the western half of the sky. So you could aim your solar panel to the west, but then you're going to miss the morning sunshine. The best direction to aim a solar panel would be to the south, which actually surprises most people. But if you aim the solar panel to the south, you'll collect some of that sunlight in the morning. You'll get most of the sun in the noontime when the sun is at its strongest and will give you the most intense sunlight. And you'll still collect sunlight in the afternoon all the way to sunset. Anyway, we'll get back to this worksheet in the next part of the video. So, make sure that you're following along with the computer animation. I think it'll really help you understand the concepts much better. And we'll do a part 2 to this for the Path of the Sun part 2.